Greetings. With me today in the studio is Ms. Manuela Huso, who works with the U.S. Geological Survey's Forest and Rangeland Ecosystem Science Center in Corvallis, Oregon, as a research statistician addressing statistical issues involved in determining the effects of wind power development on wildlife and habitats. She also serves on the White House's Office of Science and Technology Policy, Wind Wildlife Federal Taskforce. So welcome, Ms. Huso.
Thank you.
We're pleased to have you here. In reading your impressive background, I have to say that I had not heard of FRESC before. Could you give us a little background on what the center does?
Sure. FRESC, as you said, is Forest and Rangeland Ecosystem Science Center. It's a mouthful. But it's one of several centers that are sponsored or part of the U.S. Geological Survey. And our mission is basically to provide scientific information and technology that support sound decision-making by managers and policymakers with respect to conservation of our natural resources. So at the center we have over a dozen what we call principal investigators. We're researchers that our expertise spans from expertise in fish, amphibians, every kind of vertebrate that you can think of, reptiles, birds and mammals, but also toxicologists, we have fire ecologists, we have landscape ecologists, we have nutrient cyclers, and of course we have a statistician. So what we do is try to provide a science-based information to those people who are making policy and resource decisions.
So are those people that you're providing information to local and federal government, but also private sector, or are you largely focused on the public sector?
So our driving forces are primarily coming from the public sector.
Okay.
Fish and Wildlife, for example, in my case, has regulatory authority over many of the species in our country. And so in order for them to make decisions based on how to regulate or how to manage those resources, they need scientific-based information. And they come to the USGS and our Forest and Rangeland Ecosystem Science Center to ask us to answer some questions for them.
Okay. So you are down here in New Zealand to present work at a conference hosted by the New Zealand Wind Energy Association. And you'll be talking on the work that you do to help lessen the impact of wind power development on wildlife. Could you speak to us a little bit more about the problem that your work addresses, which I believe is largely focused on wildlife fatality or disruption?
Yeah, so for years now, we've kind of had a sense that every once in a while there's, we've observed animals that have been killed below turbines. And then in the late 1990s in the U.S., the problem became a little bit more higher in our perception when we discovered that there were several raptors that were being killed, quite a few raptors that were being killed at a facility outside of San Francisco called Altamont. So the attention started focusing on what the effects of wind power were on raptors, and we started looking in other places. What we discovered then was something that we didn't expect, and that was that not only are raptors in California at some risk, but we also discovered in the northeastern part of the U.S. Several bats that were being killed by wind turbines. Bats are a very important part of our ecosystem. Our agricultural system basically gets a lot of free services from them, and in removing insects from the space, and so. So then people started monitoring quite heavily. That's kind of where I come in. When we go to a wind farm and we look for carcasses that are there to try and get a sense of what kinds of impact there is, what we see isn't really what happened. We have an animal may be killed by a turbine. It lands on the ground below the turbine, but as humans we can't search every single turbine. We can't search every single space. Turbines are sometimes placed in areas that are very inaccessible, and so we can't search those areas, and yet there may be animals out there. Even so, in the areas that we can search, it's not just us that are looking. It's the foxes, it's the ravens, it's the the mongoose in Hawaii, it's the feral pigs. We're in competition with all kinds of things. So they're taking their share, and then finally, when we're out there looking, we're just human. And even if we're dogs, you know, if dogs come and we're using their capacity with high scent, we don't catch everything. We don't see everything that's out there. So this is a really, in my mind, a really fun statistical problem to work on. How do we take what we see, try and measure what the probability or what the proportion is that is being removed before we even have a chance to see it, and with that then extrapolate from what we see to what really happened. Once we can do that and we can measure accurately, then we can make all kinds of comparisons and do a lot in order to help maybe reduce the problem. With those kinds of accurate measures, we can make comparisons about if we manage turbines in one way over here or in another way over here, do they result in different levels of fatality of the species? Do we see patterns across regions? Do we see that turbines with lights on them that are required because of the aviation requirements, do they tend to have higher fatalities than not? All of that is based on accurate measures, and those accurate measures are based on using appropriate statistical tools. And that's what I developed.
That does sound incredibly interesting. Can I ask you, have you found anywhere in the research that's being done that there are animals who are advantaged by the location of turbines, by perhaps that change in the predatory chain? Have you seen any statistical information?
We have. There is an example, a person who's been researching this in the Altamont, in fact. In the area in which the turbines were built, it's my understanding that prior to their building, the ranchers out there used a lot of rodenticides, that is, pesticides that kill rodents, to kill the ground squirrels that were out there. And so there weren't a whole lot of raptors that were out there foraging because there wasn't a lot of prey. When the turbines were built, they stopped killing the rodents because they didn't care whether the rodents were there or not. And that actually ended up attracting some of the raptors that we're seeing there and causing an effect. So the rodents definitely benefited. The California ground squirrels definitely benefited.
More rodents, that's what we need. So.
Yeah.
So can I ask you, how do you see your work fitting into the bigger picture of two things? One, both wildlife protection, but also the increased pressure in countries around the world to do more with renewable energy and with wind energy in particular?
I see my job as providing information. I try very, very hard, I think we all do in the USGS and in FRESC, to provide objective information. It's not our job to make the decisions. That's a job that's for the policymakers, for the society. But we feel that it's very important that the decisions that we make are based on the best available science that we have. And so that's our position, is to provide that. So that.
Now, one of the difficulties that often arises is the work that you do is very technical,
Yes.
and you're talking with policymakers who don't have the same type of background. How have you been able to bridge that communication gap? I know it's a popular topic in the U.S. right now, but how do you take the science that you have and the findings and give it to those policymakers in a way that they can better understand?
I try really hard to put it on a level that they can relate to. You know, I don't present equations in my talks. Okay. I kind of put it on an intuitive basis. For example, one way to think about what I do is to think about a party game. So it's called Stump the Statistician. Mm-hmm. You decide how many times you're going to flip a coin, and I come back in the room and you say, I see 10 heads. How many times did I flip it?
At least 10?
At least 10. There you go. Could have been 20, though. Could have been, who knows. And so I can give you my best guess, probably somewhere close to 20 times, but it could have been 10. And it could have been 30. It could have been 40. So that's essentially what I'm up against. And so hopefully something like that, an analogy in their world that they can understand, gives them a sense of why it is that even when we see 10 carcasses on the ground, we don't know exactly how many there are that we missed. And we never will. We know exactly what the probability of flipping a coin is, but we don't know how many times we flipped it, and we never will.
So one of the things I find very interesting in looking at the work that you've done is that you have worked to develop software that helps bridge the gap between the scientific models that you've created and the need for field managers to be able to actually monitor the wildlife out in the field. Could you tell us a little bit about how that works?
Yeah, I work in a very technical field. I admit statistics isn't usually the first thing that people say when I ask them what was their favorite topic in college. all of us are dealing with a huge amount of information in our fields, and it would be unreasonable, I think, to expect a wildlife manager to be an expert in the wildlife that they're managing, in the policy that they're trying to implement and conform to, as well as statistics and as well as programming. So from that perspective, I feel that offering software to managers in order to be able to let them do their job, which is to manage the resources to the best with using the best information that they can, is where we can come in. I have 3 major guiding principles when I develop software in my lab. Excuse me. And those are that, first of all, it be scientifically rigorous and peer-reviewed, so it has the scientific backing and people can trust it then. That it is open software, which means that anybody can look at the code that I use and they can see exactly what I've done. There's no black boxes. So if you have the statistics background and you can understand the code, it's open to you. And then finally, I feel it's extremely important that the software be easily accessible to anyone who's interested at no cost. So that means it's available to government managers, it's available to industry, it's available to consultants, it's available to anyone. And by providing or having those 3 guiding principles, I think that we can provide people with resources that they need to make the sound decisions that they are faced with making.
Well, that's it. So one of the areas that we focus here on the embassy, and I know is also of interest in the United States, is the fact that women tend to be underrepresented in careers in science and mathematics. I'm interested in sort of what made you choose to follow that career, but to other future scientists watching here, what would you say as they consider a career perhaps in statistics or science?
Well, you know, of course, all I can say is give them encouragement to do it. It's exciting, it's fun, it's kind of like a party game, but it lets you visit some very wonderful parts of the world, as is evidenced by my being in New Zealand. And it's also a place where you can make a difference. You can really have an impact on how we perceive the world and what kinds of decisions we as a society and inhabitants of the world share this earth with our other fellow creatures. So it can be a very important position. I
wholeheartedly agree. Now, is there anything else you wanted to add before we wrap up?
No, just that I very much appreciate being here. It's nice to be in an embassy, and I appreciate having been invited to talk with you. And
excellent.
Thank you.
Thank you very much.